What did we decide? This was the better option, light in the back, but not up front, so the screens could be seen. Was that our? It was always hard to tell with the glaring sun of death on certain days. All right.
God has shown us mercy.
We're going to end here. We've done characters, and what we want to do is we want to look at strings. Now, strings in all computer languages are actually a data structure called an array. And we will look at array data structures in chapter 7 and 8. We won't spend much time on chapter 8, but we'll spend time on chapter 7 for it. And an array is memory joined together. I've talked about arrays a little bit before as we've looked at some other constructions where there is a character stored in an individual memory slot. So a string is a collection of characters that are stored in consecutive memory. And so a string can talk about the first character, which is at memory 0, the second, and so on. It can access each character individual, but it is this collection of characters that are linked together in memory. So to make that work in Java, Java has an object. Notice there's a type here, just like when we had a scanner object that we declared it. Here we're declaring a string, we're giving it a name, and it is a collection of characters. And so it gets this memory put together. That's why it's going to be called a reference type. Java takes care of these reference types specially. They don't copy the same way other variables do. They kind of always point back to the original thing because they're a chunk of memory. You don't want to copy large chunks of memory and fill up your memory. So we will look at the details of reference types later on in chapter 9. But this is going to be one of the other types of objects we're going to work with, which is a string. So a string creates an object. In memory, we're going to be able to name it. And so we're going to name it, again, just like the scanner, where the scanner is taking stuff from the input stream, and we have methods to work on it. String is going to be taking this memory location, and it's going to be storing characters in it. And we're going to have things that will let us process the characters individually. So some of the things we can do is, well, because it fills this memory location, we can get it to return the length. So we can figure out how many characters are in a string. We can look at particular characters. I can look at the 4th or the 5th character, and I can see what's at that position. We can take 2 strings and put them together. So when I concact a string, it takes whatever the original string is, or it puts this S1 that gets added to the end of it. I can force everything to be uppercase or lowercase. Remember when we were looking at characters, we realized that upper and lowercase were only separated by 1 bit column. And so this is a method that flips that bit column on everything in the memory. Goes through and switches everything to uppercase and lowercase. You will find when you have to process text that users have entered, one of the good things you can do is get it all uppercase or lowercase sometimes so that you can do comparisons. If you're looking for a user that entered the word ostrich, but some of them have capitalized them, some of the lowercase. If you get it all uppercase or lowercase, you will be able to do your comparisons a little bit easier. So the reason we convert things are so that we don't have to check, which characters are upper or lowercase in something. We just force it to be 1, and then we can check it in that form. So these are methods that we can use with our strings. What happens with any object in Java is that there are very specific things that happen. So that variable name is the reference variable. So in the previous one we called it message. And then we use dot and the method we're calling. So this naming convention for objects that we've kind of seen with math about PAL. Math was a library that had methods in it, and we can call those. Well, when we create an object gets methods that are related to it. So the math classes that we'd call math, and we'd always have to feed it arguments because math didn't have anything in memory related to math. It had all of those. If I needed to do a power or something, I would go in and I'd have to say what my base was and what the power was. In an instance method, because I've created this collection of strings back there, that instance gets to use methods on itself. And this is something that really is the secret of object-oriented, and we're just starting to introduce this. A class that is static like math doesn't really have its own memory space. But this instant method, I can create a whole bunch of different strings that are different things, like message 1, message 2, message 3. And then when I call methods on them, they can change and mutate themselves. They become these things that adapt. And that's going to be the idea that we're going to see in objects of these instant methods, is that creation of that one instance becomes something that's flexible. But because we've made this a string thing, we're going to get these methods associated with strings. Objects get these things that they inheritance. So one of the things that we can do is, here we're using string, we're declaring this called message, and we welcome to Java, right? That whole hello world mentality. Now I can print out, I can see what the message length is. So what I'm going to do is I'm going to run through some of these examples on Eclipse back and forth. It's up to you if you want to use these examples, and then we're going to play with some of the methods on user input as we come across. But I want to take this and we're going to do this. So I already have a Java instance here set up. That's not the one I had. Yeah, it is. All right, let me come over here.
You want us to try it though?
That is up to you.
Wow, okay.
What I'm going to do here is I'm going to keep my scanner for right now. And I'm just going to, no, Zed, let me do it this way. I'm going to input one thing on scanner, so I'm going to put some comments here. Oops, Zed. And I'll get rid of these print statements for right now. All right, so I've just cleared out some space here. I want to come back to some of this stuff. So I'm going to do the welcome to Java thing, but I'm going to do it flexibly. I'm going to have an input that I'm going to input something from, and I'm going to pull the string out of it. Okay. So notice I'm using next line. That will give me a string. So the thing that we were showing there is we were using the length. So I'm just going to print out the length. You typed in plus s1.length. So I'm creating a string from what the user has typed in. Okay, it's the only difference coming through here. And then I'm using the instance method. I'm referencing the name of my string variable, and I'm asking for the length. How many characters are in it? So let's run this. And let's see. What did they say? Welcome to Java. And it counted up the characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So has a way of processing and working with the memory. So the key here is I have a string variable, an instance. When I reference that instance back, I have methods that will work on whatever is contained in this. These things get joined together now. that whatever I have in this string, the length isn't asking for anything in here. It's looking back at this object that was created. It's kind of unique to what we've been doing before. We've done a little bit of it with the scanner object, right? When we had scanner, we had these next, right? Similar thing here, input.next. This is working back on that scanner object. But the scanner object was something that connected us with the input-output. Right? Here, we have an instance in memory that we're accessing. So as you play with these things, just kind of get comfortable with the structure, because you're going to have to make your own instances at one point. All right. And so that was the idea of what we did here. We were able to get the length using this call on that. Well, I can get particular characters from a string. And this is a much better way of how it's shown in memory. This entire thing fills memory, but when I talked about arrays before, remember, here's the starting memory address. So if I want to look at the first memory address, if I know the starting point, I want to add to it 0. And as we get to arrays, this is going to be, again, strings are a really nice way of introducing what arrays do. But let's say I'm going to write this downwards. WELCOME. I'll just leave it this far for right now. And the reason why we're going to say this is 0, 1, 2, 3, 4, 5, 6, 7, 5, 6 is this actually points to a memory address that the computer can access. Let me make something I can do in my head. 2502 is that address. So when I need to reference it and I need to see what's in the first character, well, a character is a byte long. Right? This is 1 byte long. Or 1 word long. Right. If we looked at the Unicode characters, they were the two hexadecimal places that were 8 bits each, so 1 word was 16 bits. We looked at the Unicode, then we had the /U, and it could be like the CD05, that coding for it. Yeah. So this has a given length. And so if I want to find the next thing down, and let's see, I have a 32, so the next address space would be here. Well, to get there, to find the character there, I'm taking 2502 and I'm adding to it 1 times that 16-bit word length. That's how the computer does it underneath. So if I need to get to the first thing, I need to add to it 0 times that, because that's going to point to the first address. If I need to get to the 5th thing, then the computer needs to look at this and go, well, the 5th thing will be in the 4th memory spot. So 4 times 16. And that way the computer can keep track of the addresses in it. But it causes this thing that we're going to see with arrays, that the first thing is your 0th element. Because it has to do this multiplication and add it to the starting address. So to get to your starting address, you have to multiply by 0 and then add it back. It's a legacy of what's going on underneath the computer, and it screws everyone up when they play with arrays. That means there's 7 characters here. This has a length of 7, but if I want to get to the last thing, I have to do message at char, in this case 6. It's not the 6th character, it's the 7th character. Everything's kind of offset by 1. And it's due to the multiplication that needs to happen here. And it's just how the computer has to address itself. If you work with other computer languages, some of them actually change this. R as a statistical language will address arrays. Because they're working with mathematics, they call the first thing 1. They call the second thing 2. So there are some languages that don't follow this convention. Almost any pure computer science language does, because it's how the memory underneath is being accessed. Questions?
No.
All right, so let's go back and let's try to find a character in my my program. So I'm going to come here, and so I can get someone to enter a string. I guess I'm going to enter a number afterwards. So let's say I'll do an integer position equals input dot next int. So I'm going to ask a lot of my users here. I'm going to keep how many characters are typed, but then I'm going to print out the character at a particular position. So I'll just print my integer, what do I call it? Pos position. Is the character. And what did I call that thing? I called it s1 dot char at pos. All right, so I've given myself an extra input here. Okay, I'm going to ask the user to type two things: a message and a character, or a position. I'm still getting the length of S1 because I'm referencing S1, but now I'm going to ask for it to display whatever character is at the position the user typed. So let's see here. I'm going to type the welcome to Java again because I'm non-creative right now and my brain is kind of firing on no cylinders, so I'm just going to go with the thing I did before. And now it's going to want a position. So let's start with it. Hey, what happens at the 0th position? So I typed in the same thing. There were 16 characters. And at the 0th position is the first character, that W. So it's doing what I need it to do, I hope. All right, let me give that a little more room there.
You would just be plain 2502 there.
Pardon?
No, it'd be 2503 because you have to add 1 to it. No, 1 times 0. Oh, yeah.
Anything times 0 is 0.
Yeah,
So you don't add
yeah,
anything, you
yeah.
don't add anything to it at all.
I just realized what I was doing.
So there's 16 characters here. So what value, what position should the exclamation point be in? If this is the 16th character, what position is it in? 15. So let's see if that works, right? We'll just keep playing with this a little bit, see. So, welcome to Java, exclamation point. And we said 15, right?
Yeah.
And hey, was able to pull off that was the character in there.
Ah.
So we're able to start kind of ripping apart text. This is like the bread and butter of a lot of computer programs, is taking what the user entered and breaking it down into usable chunks. One of the things, we've been using this input next line. That's literally going through looking for whenever there's a blank space. Right? So, an enter key. You hit an enter key. We'll grab everything before the enter key. So some of the things happening in the background of these things we've been using before, they're kind of cycling through these positions looking for certain characters for us. And we'll find when we have to process data that's what we need to do, is we might need to look at certain positions. All right, so what do you want to do? What is the thing you want to do right now if you have this phrase in here? What position do you want to look at? What is your curiosity screaming you to look at?
7.
Okay, you look at 7. I'm really curious what's at 16.
Okay. Sure, why not?
I get an error.
Error.
My index is out of bounds. Literally right now, this is a huge thing in the United States government. It's called memory protection. Right, when you have arrays, and arrays look through at a certain distance going through, there are certain programming languages where you can peek past memory. You can actually look at any memory that you want, which means you can glance memory inside the computer that isn't part of your program. Might be part of the operating system. Might be where a password went through, right? there were a couple years ago, there was a huge password hack because of what was the way Intel processors had to deal with when computer processors run, they actually run the code more than once with a kind of a look-ahead value. And the way that was manipulating memory, people found that you could look into some of the thrown-away memory spaces, and on certain systems it would give you escalation of privileges or viewing what was in the password space. So right now the U.S. government's requiring any contract with programs going through to be what are called memory-safe programs. I'm not sure I like that. I think there's some C and C++ that you can learn to program in memory-safe ways, but Java's a now government-accepted programming language because it keeps your memory safe. And this is kind of an example of that. I can't look past the memory that's set aside for the object.
Those fail-safes.
Yeah. They come at costs, but yeah, there are fail-safes in here. And so it doesn't allow me to do programs that do that. Also means that I lose the ability to do some low-level stuff, right? I need to write drivers or whatnot. You have to go in and, well, do drivers need to be memory safe or not? How can you access things? What layers of the OS do you have things for? Are you writing on the OS level, or are you writing on the hardware level, or are you writing in user space? But so that's all. I don't know. My question is, if I have 0 to 16 or 0 to 15, what's going to happen if I pass that limit? Well, this is what happens. You'll get an error. And so, since I'm silly, I'll also go the other way. Let's look at -2. That broke it. So I got another out of bounds exception, but in a slightly different way.
So try and get yourself to divide by 0.
No,
Or worse.
no, I was just trying to look forward on it. Some people play with Python. Python actually has this idea that you can scroll past the string and scroll before the string. It'll look at -2 as going backwards 2 characters. So other languages have this idea of negative positioning as going from the end backwards 2. Java doesn't. So some things, we've learned some parameters, right? But by playing with it, we can see some of the things this does or doesn't do. Does that make sense? Yeah. Right? And so Java keeps us forced within the parameter space of whatever that object was. Again, converting strings, the 2 lowercase and 2 uppercase will change this. So welcome changes this all to lowercase, and this changes this all to uppercase. Trim will get rid of blank characters. So there's a space put into here. Trim trims the white space on the end of it. There's some nice tidying things. Again, we just did a whole bunch of if statements, if else statements. Think about a user typing something and you want a word. Getting rid of white space at the end and forcing it to be all the same way makes your if statements not have to be so hard. Right? If I need to know someone typed in exit and they could have typed in capital E X I T space, a trim and a convert to lowercase makes my comparison. Did they type in EXIT all lowercase? If they typed in E accidentally hit shift exit, right? Shift X IT, a conversion of case works. Some programs it's just better to force everything to one case in your comparisons. For other things like your command line, some things are case sensitive, right? You have some things you want case sensitive, some things you don't. When you're doing user interfaces, the ability to turn that on and off is something you might want to think about in your programming as you need to put strings together. All right, string concatenation. Concatenation. I'm not sure I've ever said this word right. Concatenation. I think I say concatenation, like I add a k into it. Concatenation. What it does is it does the same thing as the plus sign we've been using in print statements. The plus sign puts the 2 strings together and puts them together in such a way that you get a string outwards. We've been using print where print has been taking strings for us. But when we've done system.out.println, it's been doing strings. And so we've been using the plus sign to put in the string that comes out of a number. Or we've been using the plus sign to put in a number and then in some message. Right? If we look over at what I did here. All right. This whole thing is going into print as one string. It sees this string plus whatever string comes out of this. It converts this number into a string. Print's being nice to us, right? It's doing a lot of the work for us. That's built in to the system.out.println. It has a lot of these conversions coming through. And so this is concatenating 3 different strings. The words you typed in, whatever number comes out of S1 length, and space characters. And it makes one big string out of it. You might want to do that yourself sometimes. And so you do that. You can also use concatenation. So I can take an instance of string 1, and by using the concat command, I can place at the end of it string 2. The nice thing about this is that it comes out into this new string 3 thing. So here we can look at concatenation. When numbers come out, they get converted to strings. So 3 collections of strings, right? A string and a number. The number gets changed into a string here. A string and a character. This is one character. Notice the single quotes for an individual character versus the double quotes for a string, right? And that character gets plopped onto the end of the string. Java's doing a lot of that intelligently for you. Not all languages do that, but Java's going to take care of that for you. All right, so we've been, we can read things from the scanner. Now, I can read a string by asking for next. But we've been asking for like next integer and next double previously because we were pulling numbers off. But if I ask for next, it will grab all of the characters separated by white space. So the first string, if I can enter some words separated by white space, this will pull the first word, this will pull the second word, this will pull the third word. So I'm going to do this right here. We're going to enter 3 strings separated by white space. And I think we'll go through and make sure that we can create this from the get-go. I just want to, 3 words by white space. So let's definitely all get this one together because this will start getting us to play some things. So I'm going to come over here. I'm going to create a new class. And I'm going to call this string practice, I guess. I'm not really getting very creative with names today and messages. Sorry. Welcome to Java. Hi, I'm Jeff. This is string practice. Sorry. All right, so I'm going to come here. So I'm going to make sure that I have, what do I need? I need to import. Make sure I do have the right, Java util. I always capitalize this in my head. And then, so I'm going to create my scanner.
You did Java util system, not scanner.
Oh, thank you. I was more worried about the capital J in Java. All right, so let's make a new scanner object. I'll call it input. New system.in. And I'm going to really quickly close in. Again, input. I still don't understand why your book doesn't do that often. And so we how did it say? It said, please enter 3 words separated by spaces. So let's ask our user to do that, because I'm the user right now, but it might be someone else some other time. Please enter 3 words separated by spaces. By spaces. And so now I needed 3 strings. So I think the book called them S1, S2, S3. So I'm going to say string S1 equals input dot next. So this next syntax is going to use the white space to separate them. String 2 input dot next. And string S3. Is that 3 of them? Did I count up to 3 properly? It's been one of those days I've been doing a lot of weird math. I can count to 3 still. Okay. Well. And so, well, let's play with these. Let's play with some of the other methods. So we'll take the 3 things and we'll print them out differently. So I think I'm going to take S1 and I'm going to change it to lowercase. So whatever I type for S1 will be lowercase. Whatever I do for S2 will make uppercase, I guess. And then I don't know. What do we say for giggles? We'll just make S3 whatever S3 is. Is that all right with you guys?
Yeah, sure.
S3. All right. I think I have enough, and I haven't broken things too horribly. Let's see if this works. Please enter 3 words separated by spaces. Oh, let's not be rude. Let's go. How many people are from New England?
One listener.
All right. Don't look at what I'm going to do next.
You're gonna do something offensive to my culture.
So it used the space as the criteria to break them apart. I forced the first word to all be lowercase. I forced the second word to be uppercase, and I didn't do anything with the last one. So we have these things, we can rip them apart. I hope you can see now that we've started to step a little bit away from numbers. Like we started with computing where numbers were there. That strings are based out of characters, which are numbers in their core. But we now have this ability to really start processing language. Options, things that aren't numbers, right? Everything we've been doing before is, can I add something? Can I multiply something? Can I subtract it? Can you give me some number? Right? We're now starting to step out of it. And so we have to kind of deal with language, right? And letters. And so these tools are going to be based out of that. I hope you can also appreciate that dealing with language should be much harder than dealing with pure number. All right. Well, what I have been using is next line. Next line takes everything up until you hit enter. So next, because line is enter is the thing that gives you a new line on the computer. So this can force your character or your character. Sorry, reading up there. Forces your user to interact with the enter key. All right. Well, we can do if statements on strings. We can actually compare strings to one another with some built-in features. Strings will not return an equal when I compare them one to one because they're array references. To actually see if strings are equal, a function needs to run through and compare each character one at a time. It doesn't spit out it's not like a number that the computer can look at. It can't say 98 is equal to 98 as a value. It has to go through and look at each character to do that. So there's a method called equals. We can check to see if a string is equal to another string. We can look for it to equal ignoring case. So I'm going to play with equals. All right, I'm going to go back to the enter three strings here, and I'm going to compare string 1 and 2. So I'm going to use this equals if string 1 is equal to string 2. Is that fair? And we're going to look at what happens here. So let's come out here. I'm going to get rid of these for right now. And I'm going to say if... Well, wait, did I switch it over here? No, I didn't. Boom, 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 boom. That's what I wanted. If s2 dot equals string 1. Whoops, that's in the wrong place. Did not mean that to be in close. Need that to be in the if. Alright, so how do I want to print this? I guess I'll say S1 plus equals S2.
At least you didn't say let's go Canadians.
Pardon?
At least you didn't say let's go Canadians. We'd have some birds in the parking lot later.
No one likes Canadians.
I bleed black and gold, so.
Alright, so let's try this here and see what options we can get. So please enter 3 words separated by spaces. So I'm going to say go, go, and I'll leave the last word. These 2 tokens were identical. So my if statement got triggered because what I typed in here was exactly the same. I'm going to run it again, and I will do it this way.
Go, upper, go, lower, go.
No, notice now, because there was a case difference here, my if statement didn't get triggered.
Makes sense because they don't equal.
Well, let's fix that. So let's look at what we can do here. How about I'm going to change it to equals ignore case. Is that all right?
Yeah, let's try it.
Try it. Equals ignore case.
Yep, that worked.
We okay playing with some of these things, sir? All right. I want to play with some of these other comparison commands. You will find that as you build menuing systems, as you interact with users, interacting with text is important. So what I want you to do here is this returns a number. And it says it's greater than 0, equal to 0, or less than 0, to see if the string is greater than, equal to, or less than S1. What does that mean? So let's play with it. Let's just do a compare to. So we'll compare string 2 to, we'll print out the number, right? So notice this is going to return a number. So compare to. So I'm just going to print that number here. So let me come down here. System.out.println, and I'm only focusing on string 1 and 2 right now. So I'm going to go S2 compare to S1. So I want to see what these numbers mean. So let's play with it here. So I need to do 3 words. So I'll start with typing go, go, go. When they're the same, I get a 0. Let's capitalize the second one. It's minus 32. Does this number look familiar?
Huh? Minus 32.
S2 is negative 32 from S1. Here's S1, here's S2.
How many bits or something?
It's the difference between uppercase and lowercase. It's backwards in the ASCII table by 32. So it almost like it's doing an alphabetical order. Well, let's play with that. So let's try A to AB, right? And then I'll just, because I don't care about the third one right now. Oh, look. This one is one ahead of this one. Notice how compare to is building alphabetical order for us. It's saying that this second one is one ahead of this first one. Let's see if that keeps working. Let's play with it a little bit more. So let's see, AD, what should that be a difference of? Oh, I need my third word. There we go. 3. Well, they're the same size. Let's see what happens if we make a different size out of them. Is that okay? See how we're playing with this function just to see how we can use it. Already right now I can see it can give me something I can probably do for alphabetical order. So let's see how much of that I can do. So let's try AA and the word AAH. And then blocks. I'm not looking at the third. Huh. This comparison, they're exactly the same here. It's not one away, but it has one extra character. Really looks like if we play with these numbers, we might have a way of alphabetizing. Does that make sense? There's the sorting. So if I put A, what do you think the comparison would be? Well, notice it said, hey, we're all the same up to here, but this is now 7 characters away. So it definitely looks like we have the beginnings of a way we can alphabetize, because it is definitely taking in the size difference, right? Because the letter A comes before the letter AA. And if I were alphabetizing something, so A comes before AA, which comes before AAA. So if I compare these, this comparison should help me sort these things. But it definitely looks like I have to do multiple comparisons because AA, if I compare it to AB, so I think, let's look at these 3 differences. So my first word's going to be A, and my second word's going to be AA. So let's look at that. Am I making sense? And we're developing a numerical order from letters. And so we have a sorting mechanism that's building out.
Yeah, I think you're making sense.
So this is telling me that this one is one. If I look at these 2 things, this one comes one step later. Yeah?
Can you check on a good off?
I can try.
Scroll up. So what's happening here is the package first day is not being seen. So this whole everything the first day is not seen. I just wait for him here. Wait for the pause. And do that. And do it there. And see if we can see the package. Copy it to everything but the package right there. Yeah, I think something in here, it's not seeing the package properly, so it can't reference all the junk stuff back. It's easier doing this than trying to figure out what the problem is in that. Is that fair?
Yeah.
All right. Yeah, I've been seeing that with some of your stuff, if a package gets messed up. All right, so I think we have the ability now to kind of, you can start alphabetizing words. You can start categorizing words. You can say one word is longer than another word. Let me run this here. So if my first word is please, and my second word is ketchup, 2, 4, 6, 2, 4, 6, 7. Oops, and I still need my blah at the end. Please, alphabetically, P is before K. So it gave me a negative, or after K. Sorry. Sorry. K comes before P. I'm comparing 2 to this. It's telling me this goes backwards to the thing I'm comparing it by. So do you see how we have the ability that we can start moving and comparing strings around? Yeah.
My only question is, what's like the application you would use this for? Like, how would you use this in a program?
So let's say that you have data, and you're sorting through data, and you need it to be alphabetized in its storage. Let's say you have a class roster, and you're pulling it from the data, but you're getting it in however it's entered. So you need to do an alphabetized list. When you can compare to, you can do it. And we're going to do, once we do arrays, we're going to do some sorting, where we can sort 10, 12 things into an order. Well, here we can do an order now based on alphabetizing. And if we have, atoms and atom, right, as names, well, then the atom is going to come before atoms, because this compare is numerically giving us a way to say which one's before or after. Is that?
Yeah. No,
Yeah. So trust me, doing it this way is a hell of a lot easier than doing it by hand. I will probably ask when we do arrays that we will do 1 or 2 by hand, where we look at each character, just so we get a feel of what's happening under the hood for this comparative function. Okay? But we have a built-in function that's handling some of the load for us. And at least when I look at 2 things, I can say, hey, that's up ahead or that's down below. And that lets us go sorting. And one of the things you'll find is when you sort, you can kind of think of it as like a deck of cards. You'll get the first one to the second one. Does this one go up above? And you kind of shift that card until it's done. And then now you shift the next card, and eventually your bottom works. It's all the way through. It bubbles up. It bubbles its way through until everything's in order. You have to go through the deck a couple times, right? But everything will bubble up into order. Okay?
Yeah.
Okay. Yeah, I know. It's weird stuff. All right. So compared to... guys ever look at Windows? This gets hard these days. And it's not as well implemented as it used to be. Let me see if Chrome is doing it. Nope. See text. Yeah. So old Windows, notice how they have an underlying character on it, right? This originally started with that old commands were just the letter it started with, certain command systems, and then they became shortcuts. So if I hit Control F, whoops.
Oh, what OS is this?
Alt F, I get to drop down to the menu, and now I have another letter key coming through. Well, if it was in a command line typing, sometimes it would just look for the first letter. And if the first letter didn't have any repeats, it would run that command coming across. Other times you might have to do other comparisons on it. First letter is a quicker comparison, and so, hey, you get a starts with. What letter does it start with? Or what string does it start with, I guess is a better way of saying it. What string does it end with? All right. Okay. And here we can look at this order in a little bit of detail. So substring, I can cut this into pieces. So we can use a thing called substring, which is now a method. I'm not in comparisons here. And I can say, I'm going to take everything from a beginning index onward. So if my substring beginning index, and I say 4, I'm going to get OME space 2O space Java Java. The substring is taking that stuff onwards. I can go from a beginning to an ending index, so I could go from 0 to 6 and just get the word welcome. So let's do this. We're going to use substring here. I'm using the same program because it has inputs in it, right? And so what I'm going to do is I'm going to ask for the beginning and end index in this. Is that all right? Okay. So let's come back here. So I'm going to change this. Right? I'm going to input a string, and then I'm going to ask for my beginning and ending. So I'll make this an integer. And I'll make this next int. And I'll make this an integer. And next int. And to make it clear, I'm going to call this begin and end. Is that an all right edit? I'm trying not to retype in tons of code. And so what I want is I want S1's substring from begin to end. So I have a string coming into S1. It's going to grab the first word in the space. Then I'm going to take next integer, next integer. I think I'm going to change this to next line. Is that all right with you guys?
Sure.
Right? Because I just want to write in crazy stuff. Curious when that's not showing as being used. Oh, let's try it. I might have a small typo in here. I'm looking for it. All right, so I saw my word. Please help me. I am trapped in a computer. So that's my string. And now I need to write a beginning space and an ending space. So let's see. 0, 1, 2, 3, 4, 5, 6, 7 starts help. And 8, 9, 10. So I'm going to do from 7 to 10. Ah, I cut it off. What? Did I miscount? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I need to increase one to grab it, right?
Yeah.
Because this is really only telling me 3 characters. So let's try it again.
7 to 11.
Oh, it sounds like a grocery store, doesn't it?
It's a convenience store, yeah. The big goal. It certainly is hell.
So I'm able to work my way. So let's see, that's character 7, that's character 8, that's character 9, that's character 10, and I need one more to move my way through. So let's play with some other numbers. Let's see what's a good phrase. computer class is in a dark room. Those scary people. How's that? Is that a truth?
Yeah, kind of.
Someone give me a beginning and ending number. Going. Come on, someone.
15.
What, 5? 5.
5, 15.
5 and 15?
Yeah, sure.
So,
Turquoise.
0, 1, 2, 3, 4, 5. 6, 7, 8. What's happening here? It's definitely not moving out 10 character spaces, is it? You have turquoise. Let's see. So 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14,
Should
and
be
then 1
fine.
for the space, right?
Yeah, something wrong happened.
Why?
Shouldn't there be the I, first part of is in there?
Not if it's the same as the other one that we did.
Oh.
What is happening here? Let's look at this here.
This I would be 15.
Look at how it reads itself. It's starting at 0 and going to whatever you typed minus 1. It's asking for the position up to but not including.
Oh.
Right. We effed it up a couple times that we get to see it now working. And so we look at it, it goes to the end of the index minus 1. So whatever that ending index is, that character is not included. It's a legacy thing in about talking about where the cutoff space is. Just be aware of it, right? It'll mess you up. That's why I like playing with things sometimes. It's much easier to see the mistake when you make an assumption, and then you come back and read the manual. Oh, it's minus 1. You read the manual first, you'll forget the minus 1, right? But if you mess it up a couple times. And I've messed up like every coding documentation possible. So let's go back and make this work for us then. So let's type the welcome to Java, and we're going to want to get the word to out of it. So I'm going to run this again. And so if I'll enter this in, I need to start at 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to need 8, 9, and 1 more to include. So 8 and 10. And I got what I needed. So now that we know how it works, we can get a little predictable for it. Another thing you can do is you can find where certain characters are in a string. So remember how I've been saying next line has been breaking based off of white space, and what we want to be able to do? Well, we can go, hey, let's find the first space. We can put the character for space in here. And we can come through and we can start from, and it will run all the way through. If it doesn't match, we get a -1. If it does match, we get the position of that character. So we can go through a whole bunch of text entered, and we can go, when did the user write an asterisk? Let's say they're typing in a math equation. We could pull out the numbers, find the asterisks in it for the multiplications. We could break it apart by looking for those individual characters. We can look for another string inside of a string. So if we're looking for last names that have son in them, right? So you go through each string, find where the word son and go, hey, you're Thompson, so that must be your Tom's son, right? You can break it apart because you can find these parts of it. And so we can get the index where certain things occur. And so this will find the first occurrence. This will find the last occurrence. So think about reading a whole bunch of text, right? You can take your text and you can find the first occurrence of a word you're searching for, right?
Sort of.
You could, what?
You can kind of sort it though.
What do you mean sort it?
Well, not sort, filter.
Right. That's you filter by going through and finding your first occurrence of a word. You can break because you have the index of the first filter of that word. You can break it into a substring. You can throw away everything you looked for before you found the first part of the word, right? So you have the position of it. Now you can cut off that word and you can continue looking for the next occurrence, and so on and so on. You can tell it when to stop for the last occurrence. You ever have your PDF open and you hit Control-Alt-F and you type in a word that tells you how many times it's repeated in there and points out where it does?
Yeah, I never noticed that.
That's what this is doing.
Huh.
Or that's what this is what that is doing. Sorry, I got my pronouns wrong in the wrong place. And so you can make a searching index. You can find all the indexes as things coming through. Right now, with this, you have the capability, someone can type in a letter and you can find every time the word he appears or the word at appears, because you can work your way through. And you can find the first occurrence, chop off that string, find the next occurrence. And then you can tell when you've gotten to the last occurrence, you're done. See how quickly we've elevated ourselves to now we can process text in many different ways. And that we can process characters. So let's find this. Let's take this and let's look for a particular word in this. Let's see. Let's just find the index of when a string occurs. So we're going to use index of, and we're going to put a string in. Okay. So we're just going to use the simpler form of it right now. So let's see. I can do a next line, and let's say the string I'm going to look for that I want to search for, and it will be S2. So I'm going to enter a whole bunch of text, and then I'm going to look for when it occurs. So what I want to see is when it first occurs. So S1 index of, did I spell S2. So I'm asking where is the first occurrence of S2. Okay?
Yeah.
We all right with that? Does that make sense with the methods? It's hard looking, like I get you guys like this, so I have no facial expressions, I just have eyes. So sometimes a nod helps there. Okay, so let's see. There once was a man from Nan. No, I can't do that, can I?
Yes, I
But this is where we were not to go. So we will keep typing. And the word I'm going to look for is we.
I mean, I know they're.
I get all the way here to the 57th index,
Yeah.
and we begins. Right, that's my toe in the door, right? I can find out where this is. I could make a substring. So let me do this here. I'll just print the substring. And I'm going to feed it Look at the fun I'm having here. I'm asking for a substring, and I'm going to feed it wherever that starting position is. See how I stack those together? I'm gonna cut my string, and I'm gonna do it wherever that word begins. And most of the time, I'd probably come up here and I'd say, let my index equal S1 dot index of S2 and make it a variable to hold it. But let's be tricky and kind of snobby and put it all in one place. Like we're playing golf. All right, so let's see here. I won't do an Nantucket thing. I will say, looking out upon the rainy day, drear and gray, made one want to look ahead for summer days. And let's look for the word day, the first occurrence of the word day. So day occurs at 27, and I cut from 27 on. All right. So we have the ability to start slicing things apart. I could, move 3 spaces forward, cut here, and then look for the next word day, which would give me the last one. So you see how we can start chopping up these strings based on what we see in them? Changing between strings and numbers doesn't always happen intuitively with everything we use. There is an element called parse integer. And it will take something that's a string and turn it into an integer that can hold in memory. Right now, the tools we've been using, next integer, does this automatically inside. But if you're throwing something around in memory, or you're reading in something a user typed, let's say the user types in 123.48, and you're going to parse on that period and grab the front part to an integer, the string you feed it needs to use this parse integer. It will turn that string into an integer. And if you wanted the whole double, like if someone wrote a sentence, my height is 69.4 inches, and you needed to turn that into something going through, you could find the numbers in there, or you could find the decimal point, and you could take a substring. And that substring, if you parse it, will turn it into a double. So the ability to read text as not just being text and turn them into numbers, these are the functions right here, integer.parse integer and double.parse double. Next has been doing that for us. Next integer and next double has been doing that for us. But if you get a huge chunk of text and it's your job to find numbers in it, well, number characters have certain ASCII values, right? You can hunt for them. Once you find them, you could turn them into actual values. So these string tools become fairly well. I think that is the last thing I want to talk about, and we'll do that when we get back, is printf statements. And we have what? Is it 5:15 or 5:20?
5:20.
I'll give you your full 7 minutes then, if that's fair. Very ancient statements. These go all the way back to COBOL. And COBOL had this thing called formatted print. Now, the old printers that came out, they had green paper, they were set line format, and they print things across. When you're putting data into it, you would limit how many spaces the data could take. And so you would tell your program that I want to print.
I've seen that before. That old printing paper.
So formatting output, you would tell your program, I want you to print an integer, space, you would put your format, and maybe I would say amount, right? You could have your text in here, and then you'd have this floating point with 3 decimal places, or 2 decimal places. And so you would have this line here that these special characters would get the input for your numbers. And then you could have the rest of your words in. So like if you wanted to fill in a check or you wanted to fill in a dollar amount and there were certain words in there, you could have the words in the string, and then these placeholders would convert whatever number you threw into it. So they would do that integer parse integer or that double parse double. And what that ended up doing was there was tons of tools that got around these format statements. So I could tell, hey, I want a Boolean value. So if I had a variable that was Boolean value, and I would print it out, if I put the %b in there, so how I'll format %b is the truth value. And then I would pass to the, let's say my Boolean value was a test, right? Somewhere up here I had bool in is test. What the compiler does is it looks at what this value was. And since this is Boolean, if this was true, instead of putting a 1 or a 0 here, it'd put the word true. If it were false, it'd put the word false, because it would leave space for that. If I wanted a single character, I would put a %c. If I wanted an integer, %d. If I wanted a floating point number, %f. If I wanted scientific notation, %e. So remember when we were doing the population and we were getting all these floating point numbers that were the default? You could force it to do a decimal version by asking for %f. And so what we see is we get a special system.out.print formatted. And then I put my words in and I say, hey, I want an integer here and an amount here. Once my string is done, I pass it the variables in the order they appear in it. Notice how antiquated that is, right? I need to keep track of the order these things appear, and then that order needs to be there. You can tell this is ancient computer stuff, right? Because it kind of has this, you put in an order and we'll spill back the order on it. And so when it goes to print out, it'll say count is whatever's within the value for D here, which is 5, and amount, and it will automatically do a set amount of decimal places. So this gets really, really nice. If you remember the table of values that you did for the powers, right? You could now do one line, %D, 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 1, 2, 3, 4, %D, in the format that had to all and then you could go A, math.pow, A squared, and so on. And you could drop things into the right place. But what's really nice about this is that you can match the spaces in here. You could line up, and you get each line to line up into your table, so you only need to print it once. There is one more thing in printf. I will put this up here. Your book doesn't go into it, but printf can take the number of digits. So if I did D.8, that would reserve 8 digits for the decimal. And so if I put in the number 2, there would be 7 spaces in the number 2. If I put in the number 521, there would be 5 spaces and 521. And so think of how that can start lining things up. Remember when you did that table and shit didn't line up easily? You had to go back in, right? That one of the reasons I wanted you to do that is you needed to count what your different numbers were. And now when we come in here, you can say, okay, I'm going to need 5 places for this number, and I'm just going to put a tab in between them. And now you can kind of move things about in one line.
Yeah.
That's where we'll start when we get back. You got 2 minutes. Questions, comments, queries, concerns? Things you want, things you need. All right, we're doing midterm. What we're going to do for a midterm is you have to read code. It is based on up to chapter 4. I wanted to make sure chapter 4 was done. I'm thinking the week we get back, we talk about when you're going to be ready for that. All right. Okay. Well, I'm going to give you some code. You're going to sit there and you're going to write down what it does. It's reading code. The more important aspect of this isn't that you get it perfect, but that you know what certain sections and blockings do. It's not going to be code with errors in it. It's not going to be code that I want you to correct. It's just going to be how can you figure out what someone's trying to do in their code. And so a lot of it is figuring out what the different sections will do with the code. It's probably, as again, when I talked to Tina, who's in charge of the comp sci program here, one of the things the advisory board asks more than anything else is, can you read other people's code? Because that's what you work with more often than not. Very rarely do you sit down and have nothing and start with code. 10 to 1, you start with someone else's crap. I'm going to give you some of my crap. Okay. You're going to tell me what it does.
Okay.
All right, go forth, be well, have a good break. If you need anything, scream at me.